Hello, my name is Enrique Gabrick. Now I am working as a postdoctoral at Institute of Physics, University of São Paulo, with Professor Iberê Caldas. My background is in physics, where I study mostly chaotic dynamics in epidemic models during my PhD. But today I will talk about the importance of climate variables on dengue forecasting. Dengue is a viral infection disease, which is a vector-borne disease, which is transmitted to humans through bites of infected mosquitoes, mainly the Aedes aegypti. In the last 2 decades, the case globally reported increased a lot, going from 500,000 cases in the beginning of the century to 5.2 million in 2019. Dengue is transmitted by this vector, which has a strongly dependence on climate conditions. For example, the life cycle of the mosquito follow this representation. The female mosquito bites, the susceptible female mosquitoes bites one human, susceptible humans, to take his blood to egg production. After that, it deposits the eggs in a reservoir of water, where these eggs stay between 1 and 2 days and then become a larvae under proper climate and environmental conditions. After around 1 week, it becomes a pupa, and after 2 or 3 days, it becomes an adult mosquito, which has around this life cycle. The susceptible mosquito can bite an infected human and then acquire the virus and then transmit it to a susceptible human that acquire the virus and has these symptoms. Dengue has 4 serotypes, dengue 1, 2, 3, and 4. If you are infected by one serotype, you get permanent immunity against it, but temporary cross immunity against the others. However, secondary infections, you have more probability to evolve to hemorrhagic dengue fever, and then you can die. The probability is low, but you can die. Mostly, the case of dengue, they are spread around tropical and subtropical countries. This is a data from 2013, where we observe in red completely presence of dengue, and in green the completely absence. However, this scenario has been changing in the last years, mostly because the intensification of trade routes and climate change. For example, some countries in Europe, like Spain, Italy, and other countries in this region, and also United States, now because the climate change, they are having a proper environmental for mosquito development. Then we observe from the previous graphic that now dengue is spreading in other countries. In such a way that climate is a very important to dengue spread. In this way, our goal is to study how climate variables, including temperature, precipitation, and humidity, affects the dengue forecasting. To do this, we selected 3 cities in South America, Iquitos in Peru, Barranquilla in Colombia, and also Natal. The data are weekly recorded. For Natal, we around from 2016 to 2019, almost 200 weeks. For Iquitos, we consider almost 600 weeks, and for Barranquilla, almost 300 weeks. Then, considering this climate and dengue data, we recur to machine learning algorithm. We especially focus in random forest, and as input data, we consider the features lagged by 1 week, Then we consider cases and climate conditions from previous week to forecasting this current week. We train our algorithm considering 3 sets of features. First, just dengue cases, then climate and dengue cases, and then humidity and dengue case. And then we evaluated if it's necessary to include climate in all the cases. We split the time series according to these numbers. And first, we test for Natal. Here, I think it's not appearing, but there is a gray background here, where this green and magenta color represent the testing region for the sets just dengue and climate and dengue. But there is a magnification here with the associated errors here, and also the relative error in this other panel. Here we observe that the algorithm is able to forecast the outbreaks in both set of features. However, the better forecasting is obtained when we use just dengue case. If we include climate, then the precision is lost. This is for Natal. Now we select another seed, Iquitos. Then we test, do this apparently symmetry. We train the algorithm almost until here, and then we test the forecasting, which is magnified in this panel. We observe that both set of features is able to capture many points of the real data. However, the best case in this scenario is combining climate and dengue cases. Was the last result, we explore the Barranquilla. Now we consider humidity and also all the climate variables. The forecasting range is magnified in this panel. We observe that both set of features are able to forecast the case. However, here the best situation is using humidity and dengue cases. Then the main result of this work is that combining many set of features not always help the forecasting. One of the hypotheses for this is because dengue, the transmission of dengue highly depends on human mobility, and the climate conditions, they are affecting directly the vector. Then for next works, we will include the human mobility using real networks of mobility and also other regional characteristics. More details about these results can be found in this paper that was published in last year and also is in Spotlight in Neurophysics News. The acknowledgements. Here is the website from the group that I did my PhD. You can access, and then we keep this site update. And here's the findings. Okay.
Thank you. Thank you very much. So, once more, we have a good amount of time for questions. Many. All right, let's start. 1, 2, 3.
Okay, thank you for your presentation. I was thinking about asking you if you have considered using lags to the humidity variables that you're using. So instead of just using the climate, knowing that like the mosquito takes a while to really evolve into an adult, have you used like lags to do that? Because I think the correlation would be better, you know.
Yes, we lagged all the time series, but the best result is when you lag by 1 week.
Okay. Okay.
Possibly because from the laying of the eggs to the emergence of the full mosquito, you have about 1 week in average?
Yes, yes, it could be.
Roberto.
Thank you for the presentation. Have you tried to use other machine learning algorithms or, for instance, support vector machines or I don't know, k nearest neighbor in order to evaluate the quality of your forecasting?
We employ other machine learning algorithms, but in the paper we mostly present the random forest because was the best result. But in the end of the paper we discuss the results from other.
Okay, thank you.
Okay, Piero has booked the next question. The next curiosity.
So which climate variables have you considered? So when you say climate, what are the variables that you consider?
Temperature.
Because humidity, I think, is also part of climate.
Yes, yes, we are using precipitation, humidity, and temperature.
Thank you.
Okay, we have time for more. There you go.
Okay, very well topic. So I have a question about you climate data. Like you are using temporal series or something like that.
Yes, yes, they are time series collected from governmental agencies.
So,
but now we are using from ERA 5.
So considering that climate is a complex system, so temperature, precipitation, and all the other variables must have non-linear interaction between them.
Yes.
So if you have like, if you propose an index that can measure the interaction, I think it could be more accurate, maybe.
Yes, actually we are working in this now, like trying to observe the correlations among one time series and other. For example, temperature and its correlation with dengue case, and then precipitation and correlations with dengue case.
But also like the same idea of hypergraphs. They are all together or just correlate one by one?
No, at the first moment we are just correlated one between others, not using the.
So pairwise correlation.
Yes.
Okay. Thank you.
Okay. Let's see if there is any more questions from the audience. Yes, we have one.
So why did you choose the three cases, Natal, Iquitos, and Barranquilla?
Because they are close to equator line, and the first reason is because the data is free available.
The others not in Brazil?
Yes, there are others, but we try to get in different countries.
And what is the conclusion? How bad is the situation in all the three places?
Now I don't know in this how is like the current situation.
At the time you looked.
Yeah. The worst situation was in the last year for all the cases in South America, because we have a very strong wave of infections. Like for example, in some states of Brazil, you have more than 10 times the average of previous years, just in few weeks.
Okay. So we have reason to worry.
Yes, of course we have.
Very good.
Sorry,
yes, not very good.
I had not noticed. Before closing it, I have a question, but this is not related to talk. I just noticed there is the dashed line between Venezuela and Guyana. Is there a disputed border there? Yes?
Where? Yes.
Okay, I'll look it up later. Thank you. All right, so we are in perfect time to close this last session. So let's thank the speaker and all the speakers once more. And I will now